been pretty interesting. I've seen some really cool stuff. I think there's a lot of new fun things to try and mess around with, so that'll be good. So I'm going to start my talk in a couple minutes, but before I do, I just wanted to say this is sort of meant to be more of a, here is some things that I think would be useful, but if you guys tell me what you think would be useful, that's a lot easier for me, and I can help you guys build cool edX applications. So please keep that in mind. I don't want to start early. Somebody's probably getting a drink or going to the... I guess so, because nobody else is talking. Everybody's very quiet. Yeah, they're just like, it's like, why is this stuff broken? Why? So my name's Feanil Patel. I work at edX. I'm on the DevOps team. There's about 5 of us. We work sort of split on mostly trying to keep edX.org, which is our website, up and running and smooth and going. And we try to open source as much of the tooling we use to do that, and try to help other people stand up their own versions of the Open edX platform and make that easy to do. Because like Anant said yesterday, right? Getting to 1 billion on one website, sure, fine, whatever. But if I can get a lot of other people to do a lot of the hard work, putting a little bit of upfront effort, definitely worth it. So if I can make it so that you guys can deploy your stuff and scale to a few 100 million students yourself, great. So out of curiosity, how many people currently run their own instance of Open edX? Wow, all right. How many of you guys use the configuration repo that Open edX has open source? Cool, cool. All right, this is very helpful information. How many people write their own playbooks, if they know what I'm talking about? All right, great, cool. How many people have not heard of Ansible before? Right. Just the troublemakers. Everybody can hear me okay? I don't need to like get closer to this mic. A little louder? All right, I'll try to be a little louder. I also have a bit of a sore throat, so it's probably good to keep this first row kind of clear. Try not to cough on anybody, but no promises. Speaking of, so you guys are getting both parts of New England fall, right? You're getting beautiful weather yesterday and then lots and lots of cold rain today. So, but think of it this way: you'll probably be out of here before all the snow starts.
No, it's starting tonight.
Is it?
Yeah.
Oh, exciting! I love the snow. Gets all the other bikers off the road. All right. Cool. I guess we'll get started. So yeah, as I said, my name's Feanil Patel. I don't know when you guys want to start recording, but there we go. So welcome to everybody. Just a quick sort of overview of what I want to cover today. So I'm going to do a little bit of a review from my talk last time, just sort of as motivation for what I'm going to talk about today. Then I'm going to talk about Ansible Playbook and all the different parts of it. So some of you, it sounds like a lot of you are familiar with it, so some of this might be a little redundant, but I just want it there for completeness. And then variable management and sort of managing your own deploys. Quick question, actually. How many people are running off of a single machine? How many people are running off of a separate, off of multiple machines with a data store backend? So, all right, cool. All right, so if you guys remember, some of you guys have seen my talk before, but just a quick overview. I talked about sort of starting off with fairly small deployment, but even in the smallest deployment, I suggested we always have the data stores separated from the applications, just because it's hard to move those later if you need to, and so and usually you want different reliability and different sort of monitoring for those than you do for your application servers. So talked a little bit about sort of as you get bigger, your applications are going to be in more of a cluster. You're going to have multiple instances and a load balancer in front of that. You grow a little bit bigger, you'll separate those out into different. This part's going to be a little fast because it's a lot of review from last time, but so you're going to have lots of things. If you have things that change often, you're going to deploy those separately from things that don't change often. Eventually, you'll have something like this where you have. Is this easy to see for everybody? Just real quick. Okay. So you'll have things like some of the applications which you're deploying very rapidly, you'll deploy to their own clusters, but lots of things that aren't changing will be on smaller clusters. It all sort of depends on how much you can scale because it does get expensive as you start building more and more machines. And eventually you get to something complicated like this where you've got all kinds of firewalls and you've got multiple instances in multiple locations, all with load balancers out front. Back-end data stores and different clusters for each separate application that you're running. So, told you guys should do this, but I was like, I didn't really talk about how, right? So there's lots of tools to do it. The one that we like to use at edX.org and that we support for OpenEdX is Ansible. So for those who don't know, Ansible is an orchestration tool. It's basically meant to make it easier for you to manage lots of infrastructure more easily and more repeatability. It essentially does imperative task execution. So there are lots of configuration and orchestration tools that let you sort of define the state of a machine, and then it always tries to move towards that state. What Ansible does is essentially it runs a set of imperative tasks in order, which is a lot easier to reason about, which is one of the reasons that we are using it over something like Chef or Puppet. So rather than saying something should be installed or this configuration file should exist, it says it's more in the lines of first install the repository, then try to install the requirements of the repository. One of the problems when trying to do sort of deploys of code and then installing requirements based on that code is that for state-based systems, you might end up with something where the dependency graph isn't quite right, so it'll try to install the requirements from your old application code and then install your new application code later, meaning that you don't have the requirements you actually need to run your application. Ansible's a lot easier to reason about. Its power comes from lots of modules. Each module essentially takes a bit of input, does a bit of work, and provides a bit of output in JSON. So there's lots of basic OS modules for creating directories and files, for moving files and copying files, things like that. It also has a pretty nice set of cloud-related modules, not just for AWS, which is what we use for edX.org, but for OpenStack and for other deployments. So it's pretty useful. A lot of the AWS modules are actually, I think, contributed by John Jarvis and Ed Zarakor and other people from the edX team, so we're pretty familiar with them. So if you guys are using them and have issues, please, I'd be curious to hear about them. Just sort of quick overview, there are a lot of modules. They kind of keep going forever. So there's definitely a lot to check out. Check out docs.ansible.com. There's a link earlier. I'll have another one later. There's a lot of documentation there, so I'm going to try not to repeat too much of it, but I do want to sort of give you guys enough of a primer. So Ansible playbook command. This is how you run Ansible. There's lots of different pieces here, the inventory, the playbook, and overrides, and I'm going to talk about each of those. So this bit is setting up the inventory. The inventory is essentially a list of all of the servers that you want Ansible to know about. And we can take a look at sort of how it does. You can do this in one of two ways. So what you saw earlier was this Python program outputs ec2.py. So ec2.py is essentially a simple Python program. It outputs JSON. If it outputs JSON, Ansible can start consuming it and you can build your playbooks and everything off of it. You can also build an INI file which defines groups as INI sections and you can start referring to those groups. And let's take a look at an example of that. So here's an example INI file where where you're defining web servers and database servers. So and then you also have this mail server, which isn't in a group, but is a part of your inventory. So once you define a file like this, you can start referring to any of these groups in your playbooks and say, oh, I want to update the version of Git on all of my web servers. So you can just say, for web servers, run this task, or for web servers, run this playbook. And we'll get more into what that means a little bit later. The JSON output is sort of similar. It's just a big dictionary. And any name in the dictionary is a group, and it maps to a list of IP addresses or domain names. This is an example from one that we wrote for managing AWS lifecycles. So there are things that are sort of in service are machines that are happy, and then sort of terminating wait up there is referring to machines that we wanted to terminate, but we have this life cycle that prevents them from being fully terminated until after we've done some post-processing on them. So if there's something we want to do, we want to basically hit something against just those machines. This lets us do that. So if you guys are curious about how this is written, all this code is in the github.com/edX/configuration repo. And I'll have some links in here, and we'll go look at some of that in a bit. So the next big thing I want to talk about was playbooks. This is really, like, if you take away nothing else from this talk, just this next bit, super crucial. It's some of you may already know this, but I just want to go over sort of the anatomy of a playbook first. So a playbook is essentially how Ansible does orchestration at sort of good scale, right? So it starts off with, you define a playbook as essentially a list of sort of tasks on a host. So each section in the playbook, and playbooks are YAML files, so it just takes a list of items. So you define each section as a host. A host section defines, basically, it refers to groups from your inventory. So those groups we were looking at earlier of like things that are in terminating wait, things that are our database servers, or things that are our application servers. You just define that, and then you define sort of pre-tasks, roles, which we'll talk about in a bit, and post-tasks. So essentially, it's given this group, run these set of tasks against that group, and then move on to the next host group and run a different set of tasks. So this is really useful if you need to coordinate between different parts of your system. So let's say maybe you want to run a migration, and then you want to actually deploy the code that uses the database that has that migration run on it. You can do that here. Let's take a look at some examples of different playbooks. So if you wanted to say build a playbook that deploys all of your different applications, this is a small example. So here we have a list of, let's say we've defined hosts for our application, our workers, our salary workers, and for the forums. So you may decide that you want to set up the edX platform on one set of machines, and then on another set of machines you want to set up the salary workers, and then on a third you want to set up the forums and its Elasticsearch instance. So if you want to do things like that and do it all together, this is an example of how you do that. You may also want to do rolling deploys. So you may have a load balancer like we talked about earlier, and you have multiple applications that are in that load balancer. So if you want to do a rolling update and have some of your servers be available while the rest of your servers are being updated, you could do this. So this is doing one by one, right? So the example is essentially serial 1 says only do work on one machine at a time, so it'll just go serially through this. You can set that number to as high or as low as makes sense for you. So you could say if you have 10 servers, you could maybe do updates 2 by 2 or 3 by 3. So you can define a pre-task, which is pull the server out of the load balancer and make sure there's no traffic going to it. And then you can make the update, and then you can put it back in the load balancer, and you would do this, and it would essentially loop through this bit for each machine that is in your load balancer. So this would be a way of doing a rolling update. Another way of doing updates is image-based deploy. So In AWS, this is AMIs. In VMware images. In OpenStack, some other image format. So it's, or you may have, say, like a Docker instance or a Docker container that you want to deploy to a machine, things like that. So this would be more, you would have different roles that essentially make a new set of machines in your infrastructure abstraction that has the new code on it. It would then add that new set of machines to the load balancer that you already have, and then it would delete the old group, right? So it's passing in, so if you'll notice there's these roles. Roles are essentially a group of tasks, and I'll talk a little bit more about them later. But you can also pass in parameters to roles. So we can say, this is how many new machines we want. This is what the image ID is for the new image. This is the group that I want to add to the load balancer, and then this is the group that I want to delete. It's very flexible. Playbooks are extremely flexible. They're also not meant to be kept around forever. I think you should really be building playbooks for your use cases as often as possible. A little bit more detail on the image-based deploys. This might be much harder to read, but I did want to have an example in here for when you guys look at it later. This is more of a, usually when you deploy new code, you probably want to smoke test it before you just push it out the door. So here's an example where you might first bring up the new machines and then actually run a smoke test against those machines that you just brought up. And then if those smoke tests passed, you would then remove the old one. And if the smoke test failed, you would delete the new ones, or you would pull it out of the load. You would not put it in the load balancer in the first place. So it's a nice approach where you can have sort of bring up, and Ansible will let you do this. So you can register the new machines as they come up, and then you can actually run a second playbook against that registered set of machines. So you can have a new set of 10 machines come up, and then you can run some set of tests against those 10 machines to make sure that some basic level of smoke testing has happened, or you can just like hit URLs on that application if it's a web application. And if you're happy with it, then you can move on to actually remove it. Otherwise, you can say, it failed some test, so we shouldn't deploy this. So it's a little bit hard to read, but I did want to talk about that a little bit because it's important to test your stuff. So we have our own playbooks. So edX uses a lot of playbooks. They're probably going to change significantly in the next year, but they're a good example if you're curious. They are, you can find sort of Vagrant-related playbooks. So the playbooks, we use playbooks to configure the Vagrant dev stack and full stack images, if you're familiar with them. And we also use them to build our production images. So you can find under configuration in the playbooks directory the Vagrant-related ones, and they're all prefixed with Vagrant dash, to make it easy to find. And then in edX East for all of the edX.org related playbooks. If you guys have questions about them today, tomorrow, in the future, definitely find me. If you have questions after that, the OpenEdX Ops mailing list is a great place to ask. So definitely use those resources. Some interesting ones to look at are, and let's see if this will work how I want it to. Yes, okay. So, yeah, awesome. So this one is this is our continuous integration one. So one of the things we've set up at edX is we have essentially a machine that is always continuously provisioning itself using the latest versions of the application code and the latest version of the configuration repo. So I wanted to sort of talk through that bit. So it's essentially, you see this section has roles. These are all the different roles that edX has. So real quick, there are lots of roles that we've written for various things. And you guys are welcome to use them. Some of them are sort of smaller and simpler, like something that sets up Redis or something that makes sure you have some version of Oracle JDK. And others are more complicated, like the edX app role, which deploys edX platform. So back to this. So this bit, just to go over it real quick. Can everybody read this? Should I make it bigger? Bigger. All right. Where's Max when you need him? All right. So there's a bit we set up for AWS specific stuff that we use. We set up Nginx so that we can hit all of these different services. We set up some database-related local stuff. We set up Mongo, the application. We upload some test courses. We build Elasticsearch and forums. And this is building all of the things that we care about right now. And that list actually grows a lot faster than we can update this, but we try to do our best with that. So there we go. The edX provision one is actually a really interesting one to look at too. It does a little bit more of the orchestration like I was talking about. So make it a little small. If you look at the top here, it's using host localhost, because the first thing it's doing is it's defining sort of an instance, and then it's running this launch role that launches a new EC2 instance based on that information. And this information is overridable, and we'll talk about that in a little bit. But it essentially launches this new instance, which is registered to this launched variable. And then once that it has this pre-task to wait for that instance to actually come up and be reachable. And once it's done that, it will update sort of Nginx and some sort of standard sandbox-related items on that machine. So this is a sort of a real-world example. And then if there is a load balancer that is associated with it, it'll make sure that that's set up and connected, and it will tag it with a name so that it's easy to find later. So this is more of a real-world example of the playbook I was talking about earlier, where you can create instances and then start doing interesting things against those instances that you just made up. So it lets you do some pretty cool orchestration. There you go. All right. So I've been talking a lot about roles. So let me just dive in a little bit. So there are a lot of roles that we've built. There are a lot of roles out in the world. Ansible has a tool called Ansible Galaxy where you can find other ones if you're curious about how people are building these. Ours are all in the playbooks roles directory. For all of the applications that edX has actually open sourced, because we're sort of moving towards these independently deployable apps, so you're going to see more and more applications, there will usually be a role associated with each of them that is specific to that application and deploying it. Most apps usually run from one Git repository, so there's usually a mapping of a Git repo to a role. And within the role, there's a couple of conventions we follow that if you're looking in there might make it easier for you guys to read. One is if you look at the variables defined in the roles, you can find that anything with all caps is things we expect people to override. So anytime you're looking for is like, oh, how do I change this setting? There's probably an all caps variable somewhere that you can use to override those settings in your specific deployments of edX. The lowercase variables in the defaults are usually meant to be internal to the role, so it's usually things like if you have Nginx and if you have Gunicorn running, you probably want it to run just against localhost and not against the world. So by default, the Gunicorn host IP is 127.0.0.1, and the default locations for various the default sort of Debian packages or packages that you want to install before you install your application. That doesn't usually change on specific deployments. It usually changes with the code, so it's not something we expect people to need to override. So it's a convention to make it easier for people to see sort of what it is that they probably want to be paying attention to versus not. So we looked at it earlier, but where are all the roles? They're all under the playbooks roles directory. It's got everything that we use. So a bit about the layout. So in a role, there's a couple more things here that aren't up here that you guys may be aware of, but these are the four big ones that we use fairly regularly. Defaults main.yaml is where the variables are. So I got to rush through some of this. So this is the basic layout. The variables are going to be in main.yaml. The tasks are actually the imperative tasks that we talked about earlier. Meta lets you define dependencies between roles. So if you're building a role and it needs to install the JDK, we have a role to install the JDK. You can depend on that and make sure that that's run and set up before yours. So there is a bit of like graph dependencies that you can do in Ansible. Just it's a lot more obvious how it's happening. And then templates is usually where you put templates. So Ansible supports Jinja 2 templates. These templates let you build configuration files, but then replace variables later so that you can sort of have an obvious sort of skeleton for how things are configured, and then you can override it later. A lot of the new roles are built on top of the edX service role, so it uses this as a dependency. It's a base role for most new IDEs that you're going to see coming from edX and OpenEdX are going to be using the edX service role underneath. So it does the basics of deploying the code, of checking out the code, making sure that all the directories and users necessary for this are there, and creating the config files related to this application. It doesn't currently do anything with supervisor or virtualenv or anything Django specific like run migrations. That's all meant to be handled by the calling role. So some examples of things that are using it right now, the e-commerce repository, and that's the stuff for our new e-commerce work. Programs, which you'll probably hear more about in the upcoming months, and then Insights, which you may already be aware of, which is our analytics platform for providing analytics information to instructors. I did want to talk a little bit about the edX app role. So the edX app role is the base role for the edX platform code. It's what deploys sort of the core of the site. So the LMS and CMS are both deployed with this, as are the salary workers related to those. So it is not currently using the edX service role. We're hoping to change that very soon. So if you guys are looking for a project for a hackathon, I'm happy to help guide somebody through this. It also deploys themes and microsites. So unlike a lot of our other applications, this one actually deploys a couple of repositories. It also has multiple virtual environments because it uses it has to set up code jail, which lets you do jailed code execution for submissions from students. So it's a little bit more complicated than the others. But again, still imperative. You can still start with main.yaml in tasks, and you can just go through exactly what it's doing. So if you're ever running this and you run into an error, it should always show you what task it failed on, and you can go in and see exactly what it's trying to do. Something slightly different is the Nginx role. A lot of people have asked sort of why there's an Nginx role that deploys these templates instead of just deploying the Nginx bit as a part of the application. The biggest reason for that is actually because we want to be able to, there were use cases early on, and I think still exist, where we would want people to deploy an Nginx cluster separate from the application cluster. So for people who are using Nginx as their load balancing scheme, this is pretty crucial. So the templates are currently being dropped by the Nginx role on the machine where the Nginx role is run. There's been talks recently and on the mailing list about using a different tagging scheme that's been proposed, so that the templates would stay with the applications that they're related to, but you would still have it would be a different sort of paradigm for deploying them. But right now it's set up this way because of what it is. So an example of the Nginx role. So this Nginx role deploys the LMS, the CMS, XQs, certificates, and the e-commerce all to the same machine, and it makes sure that the default site is set to the LMS. All right, last bit. So variables. We start off with all the defaults that are in the roles, and edX and OpenEdX we try really hard to make sure that if you run something with the default set of variables, it will actually run. It's not always possible, but if it is, we try to make that happen. That's how the dev stacks are built, and that's how we build our sandboxes and test our continuous integration. I'm going to talk a little bit about general -e usage and what that means, and then go over sort of how we build and deploy and manage these things at for edX.org. So real quick, edX bin update. If you guys have set up single instance sandboxes using either the continuous integration or the edX sandbox roles, you'll have this edX bin update thing that you can use to update your settings locally. It runs locally on the machine where you installed the edX Ansible role, and it'll essentially run. It's an Ansible role that sets up a shell script that runs Ansible roles. Great. So it's mostly used for sandboxes. It relies on this servervars.yaml file where you can put in your own overrides. So if you're testing some new setting, or you want to test a new feature flag and you want to just override it on a sandbox and test it, you can just make your changes in servervars.yaml, and then when you do an edX bin update, or when you're making your code updates, it'll make sure the configuration doesn't get clobbered by your code update. The one big note here is this is not safe for production environments. If you guys are using single instance sandboxes with servervars.yaml that have all your passwords, this is very dangerous, right? It's a single place, it's a one-stop shop for a hacker to find all of the information related to your application, all of the third-party auth, all of the public-private keys that you're using for encrypting against, say, like some testing site. So be very careful about leaving this all in one place. So the last part of the Ansible playbook command that I talked about earlier was this -e, path to overrides. So on an Ansible playbook command, you can do a -e and provide essentially a path to a YAML file which will let you do overrides. Use this. This is great. It will let you, it means that you can put your secrets wherever you want in a separate repository that's locked down, encrypted, whatever, and you can point to it when you're running Ansible, but otherwise it's not there, right? So it's great, and it's actually how we use it. So before I talk about sort of a little bit more about how edX does it, just a quick review. At edX, we refer to things using this triple, this EDC, which is the environment, the deployment, and the cluster. So we usually have separate clusters for separate applications, but we also run multiple environments. We have a staging environment, a load test environment, et cetera. So usually when we do this, we have this triple to refer to things. The way that we build is with images. So everything is deployed as an AMI. And we use essentially, we bring up an instance that runs Ansible on itself locally, configures it, then we take a snapshot of that and we deploy that over and over again until we would need to update something about it. When we do this, we essentially have two different variable files that we do. We have sort of a deployment one, so everything that is true for edX.org, everything that is true for Edge. So this is where we would do sort of feature flagging to make sure that we have good parity between our stage and production environments. And then we have a specific one for the environment and deployment. So for stage, we would want different database credentials. We would want to point to a different database. We would want to override some features temporarily and then turn, before we push them out to production, things like that. So we usually use the separation. You could separate out into as many variable files as you want. You can use as many, you can tack on as many -es as you want to feel organized with your variables and schemes. But we found that these two are usually sufficient for good separation and ease of readability and updates. Making this stuff work for you, right? So if you guys want to be running Ansible against your infrastructure, please do, right? Rolling deploys, really easy. You can write playbooks. The roles are there and should be ready to go right now. You can also build images for your infrastructure like I talked about earlier. Sort of takeaways from this. The roles are the atoms, right? So we try to make sure that those are usually functional and we have issues. And if we have issues, we try to fix them as quickly as possible. Variables are your special snowflakes. Keep them safe and keep them yours. Don't check them into the same repository. Keep them elsewhere. And then playbooks, just build as many as you need to do what you want to do. It's a great, I think it's a really useful way to orchestrate. And throw them away if they don't work. Ours might not work for you. Currently, ours refer to hosts all, which means that anything that's in the inventory is fair game. We do this. We usually use limits as a way of deploying to the right infrastructure. But we're also building images, so often we don't need to use anything other than all, because all refers to the machine you're on. So our roles, our playbooks might not work for you guys. So don't use them if you don't need to. And if you guys, they're great examples if you're curious. And if you have questions, please reach out on the mailing list. So, and then last thing is, if you guys have bug fixes, help us make it better, right? You guys are using it for use cases that we don't have. And that doesn't mean those aren't important use cases. So if you have fixes in your forks, even if you don't think that they make sense for the community, start a discussion. Maybe there's some pattern that we're not seeing because there's 2 or 3 or 4 of you that are out there using some other way, using our stuff some other way that we didn't think about. And maybe we can make it easier. Maybe we can build that in as something that is available. Also, if you're building on new kinds of infrastructure, please, your thoughts are super important. It's not something that we can prioritize just because we don't have time to work on all of the kinds of infrastructure. But if you want to build for new infrastructure or new operating systems, we definitely want to make that better. We just need somebody else to be the leader on that, right? So I'm looking to you guys to be, to advocate for the things that you want. And PR is always welcome. I'm happy to comment and review any PRs you guys send our way. So those are links for later, and that's all I have. So thank you very much for taking the time to listen, and I can take some questions. I know I've run over a lot of my time, but come find me in the halls later also. Here, you first and then Morgan.
You said there were going to be quite a lot of changes in the upcoming year.
Mm-hmm.
Do you have a general direction for some of these?
So what I mentioned earlier that there are going to be a lot of changes. What's that? Yeah. So I mentioned earlier there was going to be a lot of changes. So the question was about sort of what kind of changes there and what direction they're going to be in. Most of the changes are probably going to be with our playbooks and the organization there. There's also going to be a bunch of changes to the roles in terms of tagging. So not necessarily reorganizing them a lot, but essentially separating them out into smaller chunks so that we can add more testing in between things. So we've been talking about internally, and I think we've made the proposal on the mailing list, and there's a link to the wiki where the proposal exists. But I can send it out again to the mailing list later today. But the idea is essentially that we can tag subsections of roles with the actual, basically make smaller modular separations so that we can run arbitrary parts of a role. So let's say you know that you don't need to update the requirements, but you just need to update the code. We want to make that a little bit easier to do. Or if you know that you need to update the requirements and the code, but you don't need to run migrations, we want to make that a little bit easier to do and have the tests built into it, or make it easy for you to say what parts you want to do so that you can pick and choose using tags which things are important to you. Because often running through the entirety of the task list means skipping over or rechecking a lot of things that you know to be true, which is great for sort of validation and compliance, but if you're in a rush sometimes that's not super helpful, so we want to make it a little bit more flexible. Morgan? Sure. Right now, I think we want to look into something like that, but the question was around how we manage secrets. Right now we manage secrets in a separate repository, so we actually just have a separate repository with a variable layout for sort of how we organize our secret vars. And when we're building, it essentially pulls in that directory plus the configuration directory. So configuration is our public. Everything in there is for the public view, and then we have essentially a configuration secure, which is where all of our overrides are. And when we're building something, we usually have both at hand. So we use the trick with -e's to point to the path for whatever we actually need. Anything else? Cool. Thanks, everybody. Enjoy the conference.